So welcome to JavaScript Applications for the Enterprise, Test More, Work Less. George and I, you might have been here at 1 o'clock for talking about developing applications for building applications and deploying them for production, getting apps production ready. And this time we're going to talk about really about testing, getting into unit testing and why that's important. George and I work in our professional services division out of DC. So we work on a lot of enterprise level applications, very large implementations. And so we have a good understanding of a lot of pain points that get associated with those type of applications. So quality assurance is important, and on large projects we know that can be really difficult. If you're really lucky, you have a dedicated QA team to help you out, but you might also be a one-man shop or one-woman shop developing applications for your organization. And regardless of that situation, we of course want to be building high quality applications, and if you do have a QA team, you probably have nightmares about delivering bad features to them and getting yelled at by them. And I'd rather be doing other work than fixing bugs that they find. And so keeping all those people happy is of course good. Another perspective besides keeping peace in your workforce is the monetary aspect of it. When your applications don't work, there is an impact there. If you're a trained software developer, computer science, you probably have heard about the software lifecycle, and it's certainly true. The later you find a bug or the later you have some sort of feature change request, right, the more costly it is. It's more costly to go redesign things, to keep going back to features instead of being able to keep pushing on to fix those. So, and if you're in professional services like we are, customers want warranty on what you build them, and we all bid that like really low, right? Because we all make the perfect stuff to start with, right? So that's just like gravy, right? So you don't want to have to eat through like double or triple your budget for that warranty work either. That's just no fun. And so there's also the perspective of the user. Users are extremely turned off by applications that don't work, and they're not going to want to come use them again. If it's an application that you are making money off of for your company, like you could be losing customers, you could be losing money by your application not working, and that's a problem. So we all have pride as developers. We want to write good code. And a good QA process and testing is a crucial part of that. So I assume all of you after today are going to be really gung-ho about testing. You're going to go back, you're going to be like, yeah, I'm going to start writing tests for my application. It's going to be fantastic. Then you're going to look at your own application and you're going to start freaking out a little bit, maybe get the shakes, crawl under your desk, cry a little bit, try to figure out how on earth do I actually implement any of what these guys told me, or I read on the internet, or whatever about testing. It's terrifying to try to add it to an existing application, even though we know it's really important to do so. So George is going to start walking us through the types of testing that there are, and how you can really start to accomplish getting this testing into your existing applications, and really what the best practices of testing are.
All right, so before we can really get into the nuts and bolts of this, it helps to get a few terms under your belt and talk about the different types of testing that exist in the world. There's really two ends of the spectrum. And the first end is the developer-focused unit tests, and that's going to be focused on the building blocks of your code, every little function, pieces of action, the logic files. In this section, you're really testing your code. You're not really testing the workflows. And the other side of that is the user-facing functional tests. Functional testing is really hard. It's super painful. Developers don't like writing functional tests. A lot of times when you start writing tests, this is what you think of. You start thinking about how does the user use the application and that sort of traditional QA workflow. But in reality, the bulk of your tests should be unit tests. You get the most bang for your buck when you're doing that. Unit tests are easier to write. It's easier to get developers to write their own unit tests, and it's easier to find errors with them. So UI testing is important. It can still be used effectively, but if you don't have any tests, you want to start on unit tests. That's where the bulk of your work is going to be. Focusing on functional testing has a tendency to wear out developers. I know when we first started down this testing journey and we wanted to get some of our larger applications, that's where we started, and we got burned out really quickly. We had a couple functional tests that we wrote, and then it kind of just stopped from there, and our code base continued to grow. With unit testing, you can really build that up and scale it out efficiently. So I'm going to go through now and show some of the basics around writing unit tests. I'm using Karma here, but you can feel free to use whatever application you want. All right, so first I'll go over the application. If you were in our earlier session, you'll notice that this is the same exact application. We did that on purpose. All the code is in our GitHub account. It's under the same repository as our other things. These things go together really well. So this application just shows a map of DC. We can add a transportation layer, take that away, an asset layer, take that away, and we can clear graphics. There's a travel ring tool, some very basic things. And so you look at this app and you're trying to think of what to test. We decided to start at the toolbar level. And we write a couple tests. We have 4 tests in here. It's not extensive by any means, but certainly better than nothing. And we've got it set up with Grunt so that I can go through here and type in grunt karma. And you'll see it'll actually bring up my browser. It'll run some tests in the browser. And it's going to do that for a little bit. And it'll spit back out on the command line whether that succeeded or failed. And you can see here, it says 4 out of 4 success. That's good stuff. Let's look at how that's set up. So in our Grunt file, we use a Karma plugin. And Grunt is just an automation tool. So it runs through, you could run Karma from the command line directly. We chose to do it through Grunt. It obfuscates some of that, pulls it out, abstracts it, lets you run other things in coordination. So in here we have some options. We get JUnit reports that we use for our other building tasks. And we get dots, which shows it on the command line. We also run JSHint, which is a JavaScript linter, and that's going to go through each little bit of our code and make sure we're not missing any semicolons, we don't have any unused variable names, or typos within our program. Very straightforward, very useful, very easy to catch bugs with that.
And if getting to unit tests is too daunting, at the very least, start using JSHint or JSLint within your application.
Definitely. So over here, we have a few folders. I have my main application folder, and then I have the spec. And spec is just Karma's way of saying tests. So within the spec, we have a main test here. And we'll look, this is just JavaScript. And what it's basically saying is run all of the tests that are named spec.js and some other stuff. We set our Dojo config because this is using Dojo since it's the Esri JavaScript API. And we do that similar to what we would do in the application. I'm setting it here to the CDN. You can set it to your own local Dojo instance. If you pull it with Bow or anything, it'll work. And then we just have a piece of boilerplate here that says to run all tests. If I look in the actual test, I can see here that it's pretty straightforward. I've got a description of my component. This is going to test the toolbar. I've got a few sample arguments. We have this before each function, and in that I'm just constructing a new toolbar with a bunch of empty arguments. And then after each, I'm destroying it. That way we get a pretty clear idea that this is a from-scratch toolbar test. I'm running each test in isolation, so we know other factors aren't being affected, and I'm just testing the function that I'm looking at. Now, when it comes time to write the actual functions, there's some rules you need to follow to make this work well. The probably single most important one for Esri JavaScript developers, or anyone using a framework, is to not test other people's code. This is really important. You don't want to test that the map is zooming in. You don't want to wait for a pop-up to show up and test what the content of a pop-up is. The JavaScript API team is already doing that. They're testing their code, you test your code. And this is going to save you a ton of time, a lot of headaches. You don't have to figure out the internal structure of the JavaScript API. You don't have to do anything like that. That sounds like it makes sense, right? But how do you actually go and do that? I mean, you can go through and write fake functions, you can pass in empty objects, but somewhere along the way, you're going to run into a dependency, something's going to break. So we use what we call spies and fakes. There's a number of libraries out there that do this. I use Jasmine that comes with a number of spies and fakes with it. And what it does is it either creates fake functions or it listens in to another function without actually calling it. So if I go back, we'll look at our code. And here I have a function that we want to test. And it's plain English. It says it clears the graphics and pop-ups. That's coming from our build application toolbar. If we look at that, it does two things, right? It calls the map views graphics layer remove all function, and it calls another function hide popup. That's getting rid of the map's popup. In the test, we look here and we look at that logic. The first thing we're doing is creating a spy object for the graphics layer. We want to listen into that remove all function without relying on the remove all function itself. And we want to listen to the toolbar's on popup function. Because this isn't testing that function, this is just testing the clearing of the graphics and the popup here, the top level function. So I call that function, and then I just check. Were both of these functions called? If they are, I know this piece of logic did its job. There's no bug here. I can test the hide popup function in another piece. And I know that if I've done everything correctly, the Esri remove all method is going to do its job too. So I don't have to test any of that. Down here, we have a very similar thing for the hide popup function. I make a fake spy object for popup.set. I hide the popup, and I ensure that set was called and that visible and false were its arguments. And as long as I'm verifying that, I know that this function is working and that it's doing its job. And that's not that hard to write, is it? You know, that's not like at which coordinate did the pop-up show up so I can see if there's text there, or which DOM node is this inner HTML. You just need to say, did this function get called? All right, so one of the other main pieces of this is that now that you're writing this sort of code where you're not testing other people's functions, you're looking through things, it's going to be easier to maintain your code too. Because normally when we developers go in and we start piecing together our programs, we write code that's really hard to test. But if you come at this and you're trying to write testable code, you'll find that down the line, this code's going to be easier to maintain. It's going to be easier for a new person to come in. You're separating your logic and your actions, and that's going to be really helpful. The normal recommendation for this is to write all your unit tests first and go through that logic, and then write the code around that. One exercise I like to do when I'm going through this is instead of writing all of my unit tests, I'll start with sort of a skeleton application or a skeleton function. So what I'll do is, in the instance of this toolbar, I'll just start writing out my function, and I'll start with the postCreate method, and I'll think about what needs to happen here. So I want to make the toolbar draggable, so I'll call make draggable function. On a click, I want to toggle transportation. I'll set up that connection, and I'll keep going through this, but I won't write any of the action blocks. I'll just write my logic out. and make sure every piece of action has its own function. So you'll see that make toolbar draggable was empty. In toggle transportation, I know that if there's no transportation layer, I want to create a new one. And if it's visible, I want to hide it, and if it's not, I want to show it. And all these are my logic layers that I can test separately and make sure that the correct functions were called. And then I can test that action separately too. And this helps you because when you run your test, you know exactly what failed and why it failed. You know whether it was a logic error, you know whether it was an error in the actual action, and you know where it is. And if anybody else goes in here and looks at my code, there's no comments in this code, but they know exactly what's going on here too. It's self-commenting, and that's super helpful. I know what you're thinking. This is great. It's good, but it won't work. I already have a huge application. It's a nightmare. I can't do this. So let's look at something that's maybe not as perfect. I have a method here that we wrote a while ago, and it's bad, right? This enable asset connect, you might recognize some of the aspects about it from some of your own code bases. We have connections and some inline functions. It does a lot, right? It's not really clear what exactly is. I can get to the middle of this function and I'm lost, right? I don't know what's happening anymore. I'm a new developer. I'm just gonna give up or change one line and hope everything works. So instead of going in and trying to write a test for this, because that's never gonna work, it's gonna turn you off from unit testing forever. What you wanna do is just start refactoring things when you wanna write a test. And it's not that complicated. I'm not gonna go through and re-architect the whole thing. I'm just gonna take everything within this function. I'm just gonna copy and paste it to another place. Take that, go down here, and I'll say on map click equals function. And just copy everything down here, and then I'll keep going. And I'll say, where's the next junction point here? I can keep going down. I find another one here. Identify task execute. I take everything out of there, copy it, and I can start seeing a little more logic here. Go through, and I keep doing that. I do that for all my if blocks here, where I can just say build project, display project error. I can do this down here too, and copy all of this, and just say set symbol, and you can start to really break it out like that. And even if you don't get through everything, you'll have smaller blocks of code, and you'll at least be able to write 1 or 2 tests and start to get that coverage flowing. And that's great for applying things where you already have a lot of code, you have a lot of headaches, but you know it's a place where bugs show up often. All right, so I went through and I showed a lot of examples in Karma. There's a million libraries out there. Intern's really popular in the Dojo community. We use Jasmine as our language here. That's just kind of how your codes are gonna look, the type of language. There's other ones such as Mocha. Synon.js does a little more complicated spy and fake framework. So it's pretty cool. A lot of these are modular. If you're missing a piece and you think you want to change something, you can usually just swap out something. So if I'm using Karma and Jasmine and I decide I want to use Mocha, you can usually swap them out. It's like JavaScript. Every framework is being developed every day. You know, in the time we've had this presentation, there's probably 5 more frameworks that were developed, became trendy, and faded from glory. So, you know, just find something you like, stick with it, and write your tests. Randy's going to talk a little bit about getting this into your overall build pipeline.
Sure. So now that we have unit tests written, George showed that we're using a task runner, Grunt, to be able to run those tests. But now we want to make sure that our code is passing those tests, no matter who commits code to our repository. or maybe we forgot to run it before that would never happen, right? You would never not run your test before committing, right? But it happens. And so developers can use those same scripts that George showed on their local machines. They can even add commands to the grunt task like watch. So it would watch files and copy them over and then automatically run the tests again through Karma. And but what we want to do now is we want to take those same scripts that we wrote in Grunt and Karma and execute them every single time somebody commits code to the repository. And so to do that, we're going to use a continuous integration server. We're going to show it with Jenkins today, but there's a lot of other ones out there as well. Travis CI is popular. Hudson's sort of fading, but still widely used. Or if you're integrating in something else that you already have, if you're using like TFS as a solution within your company or something like that. So there's lots of options to actually run these things in. So let's just sort of look like what this would look like in Jenkins. People who were here earlier got a little bit of a preview of this. And so in Jenkins, I have a whole pipeline set up here. You can see I've numbered them so it's sort of clear what the flow is. But we're starting from our test units, and then I actually have 0 through 1, I forgot 2 somewhere. But 0, 1, and 3 are linked together. When the unit tests pass, then the build happens, then it deploys to QA. And then once I'm satisfied that it passes QA, then we can manually execute the job, start the job that deploys it into production. So let's dig into this very first step. So this first step is going to look much like what George executed on the command line. We are doing a few things, housekeeping sort of things, before we ultimately get to running our grunt test task. Wrong window, there we go. So that grunt test task runs 2 things. It runs JS hit, make sure everybody's doing good JavaScript programming practices, development practices, and then we actually run our test code via Karma. So you can see we do some other things here. We're installing those node dependencies that we have. We're cleaning up some things from the previous tests that might have been in there, and then we're running our tests. So if we go back here, I'll actually kick this off. But we're doing a couple of nice things here. You can see I can come in to see my last test results. Dig down in. Currently, George and I are only running the test in Chrome. You can configure other browsers as well. We can dig into this package. We see this toolbar test that George was telling us about, and we can see each one of the individual tests, how long it even took them to run, and the status of them. So let's see if this finished running. Yep, so this test finished running, and we start to see this trend graph over here. So this is a result of the fact that I have multiple tests that have been run by Karma. It's outputting a file so that we can see the trending of how we're doing with our tests over time. You know, if a test fails, we're going to see a dip here in if one of our 3 existing tests fail, we're going to see a dip in that. What we'll also get to see is, are we really writing more tests over time? Like, because the graph will go up and show us that more and more tests are being written, and how that's coming along. Karma can also do code coverage sort of work and things like that, which you could integrate as well. So you can see here we're using unit testing is really the whole basis of our pipelines. If the unit tests don't pass, the build is not going to run. So, it's an important part of doing that for us and the workflows that we do. So going back to sort of what George was talking about in how we test our code, he sort of gave the example of writing the skeleton project, which would help him determine what tests he needed to write. Well, traditionally, what that normally looks like is, in our development practices, is we write code, then we go write our tests. And then we write more code, we break our tests, and then we errantly go and modify our tests so that they'll work with our code, when it needs to be the exact opposite. So as we start to think about what does test-driven development really mean for us, it means writing those tests first, and then making them actually fail, and then writing our code until our tests pass. So what George did was a great example of letting us sort of begin to understand what tests do I actually need to write. But none of the things that he did in that skeleton class violate what we're looking at here. So he's not writing any code that eventually later we will rewrite our test for to make it work within that. So, and then once we write our code and we pass our tests, then we always need to be constantly refactoring. Maybe you find that you need to break out and add another function, sort of like George was showing with refactoring an existing class. You constantly want to be doing that, to be adding more code coverage and really making sure that your pieces of code are broken apart properly so that you can test both the logic parts of it and just the functional parts, but make sure that you're testing your parts of that code. So a big aspect of this gets into source control. And you might be thinking, how the heck does source control relate to unit testing? Well, as we unit test things and we want to continue to develop new features, but still have good pipelines that are getting our applications out into production, we have to be careful that we're not putting in half-baked features into our source control, especially if we're using continuous integration. So some things for us to think about as we do this to manage how we're creating new features, writing new tests without affecting the rest of our code base. So in this example, we have a release candidate branch. This is going to be where we think done features are that are ready for integration testing. We might start developing a couple features. So we'll make a branch per feature. We'll have some commits. We'll start making our features, developing our tests, seeing how those are going. And we can even go as far as to utilize our continuous integration server to make separate jobs and separate tooling to run against each branch. Because then we continually know that everything is passing their tests and everything is going along properly. And Jenkins, for instance, has some tools that can help you do that with multiple branch control as well. So we think that the sum feature is done, so we're going to go ahead and merge that back into our release candidate. You can see here now we're running the tests. We have a little minor thing that got integrated in there, and we're ready for our first release. The other feature is still in progress. We're going to merge back from our release candidate. This will help us make sure that once we're really ready to add this feature to our code base, all those other things that were added to it from the sum feature, we'll pull it in, we'll run those tests along with the tests that we've already written, and really make sure that nothing we've done in our branch and nothing that they've done is going to mess up my code or their code between those two features. So we're finally done with this feature. We're going to merge it to the release candidate. All of our tests pass. We've gone through the QA. We feel like we're ready to go. So we'll merge it back to our stable branch, our trunk, our master. And now we're ready to go ahead and release that and start the process all over again.
All right. So It's a really useful method of handling source control. We got that method from GitHub themselves. That's how they manage their source control internally. If you look back at the slide deck, that graph is actually on their blog, and you can look at, they have a lot more detail about how to handle it. Some of the other resources we have available out here. We have that enterprise build sample that we've been using in our presentations this week. Feel free to go in, ask questions, may commit new code if you find something that improves the workflow, and just go for it. Another great resource is the Esri videos website. There were some great talks this week about unit testing. There were some great talks about handling your code better. Past dev summits have also had great talks. Just go to the site. Everything that you're seeing this week is going to be out there for free if you want to rewatch it or watch something you might have missed or had to make a choice about. This next video that I have here, it's a bit of a long one. It's another probably hour and a half long presentation on some of the more technical details around writing good tests, and it covers a lot more things that you'll find on the back end and more computer science-y sort of stuff. So if you're writing really big projects and you have some more of that going on, definitely check out that YouTube video. It helps a lot. This stuff is important, you know, like we tend to think of unit testing and testing in general as something to be bolted on after the fact, but in reality, it makes you write great software, it makes your code easy to understand, and it makes you have way fewer bugs. So I urge you to go back and try to incorporate into your existing projects. I know one of my goals is always to, every new project I use, to integrate some sort of testing framework and get at least the majority of my important code tested. It's not about having 100% code coverage. It's about testing those areas that are going to be widely used, testing the logic blocks, and the pieces that might break. And just any little test is going to be better than nothing.
Yeah, so George mentioned the videos.esri.com. If you didn't make the session yesterday, there was a testing session yesterday that would be a good one to go watch later on as well. And if you search on there for testing, there was one that's from a couple years ago. Tom Wyson and Dave Bowman did the majority of that session, I think it was, and that one's really great as well. Yeah.
All right, so we hope you enjoyed the talk. Please go take the survey, rate us, give us some feedback, hopefully good feedback. We really use this feedback year after year to try to improve our talks. I know since the last few years we've been doing this, we've modified our presentations quite a bit based on the feedback, so it definitely helps. And we have some time now, so if anybody has any questions, we'd love to answer them. Sure, can't see you with the podium here. No worries, you're good. That's a great question. Okay. Can I answer that first question first, and then we'll, just while it's on the top of my head. So the question was, while we were talking about not testing other people's code, you have edge cases where you might be passing in the wrong parameters into someone else's function, or expecting an invalid return value, or not expecting a return value that might happen more often. And the way we get around that is by similar using spies and fakes. So in that pop-up method, one of the things I was testing was which parameters were being passed in there. So I said, you know, make sure this function was called and make sure the parameters I was passing were set and visible, or visible true. And what you can do also is you can test what kind of parameters there are. You could check a regex. You could say, make sure that the parameter I'm passing follows this regex. You say, make sure it's this instance type. You could say, make sure it's a string. Any number of things like that. You can also do things like pass to a function and get back and have it give you a fake return value. And that way you can test specific return values of that function. Most of the time, what we're going to want to do is we're going to want to handle return values in a completely separate function that you can test. And then you can just add individual tests for different types of return values. So if you run into that edge case bug, right, if a function returns something you weren't expecting, you had no idea that library could do that, and it fails in a production environment, it was going to fail like that anyway, right, because you didn't know about it beforehand. But now that you saw that, before you go in and fix that bug, you're going to want to write a new unit test that mocks that return value, right? So you'll write something that just says, what do I do with this return value? And your test is going to fail right away because you know it's a bug, and you fix your code, you wait for the test to pass, and then you commit. Does that help? Great.
The other thing, the second question was about, you were talking about refactoring by taking blocks of code and separating it into separate functions. But in a language like JavaScript, for example, that could break lexical scoping, which you move the code to a new place where it's no longer in the same lexical scope. You have to, I guess it's just really a comment that you have to do that carefully. But what are your suggestions about how you can ensure that you're not doing it?
Sure. The question was about lexical scoping and how we can ensure when we're refactoring code that we don't break the scoping, because JavaScript is super weird about scope. And the answer to that is it can be hard and you have to be careful, right? But you also can do a few things when you're designing your code to make sure scoping doesn't bite you. One thing that's pretty important is you can change where you're declaring your variables and move them up in the function, right? So that you don't get confused, so you're not reusing variable names elsewhere. JS hint will help you a lot with that. And also some of the newer ES6 functions like let and const can help you manage your scoping better. The other thing is when you're pulling it out, continue to test with each section. I went through and I took out a lot of things at once for the sake of the demo, but in real life that's not how it's going to work, right? You're going to take out one section of an if block, put in another function, and test that and make sure it works.
Well, and I think the other thing that George did during that section that you can key on to specifically address this lexical scoping issue is he didn't copy the function out and just put a name in front of it. He copied the logic within the function itself and created a new function with it in it. So if he needed then to pass in, if that function needed things that were scoped above, they can become parameters of the new function that he's created. And so if he was calling that that onIdentify complete method, for instance, that he made, if there was something scoped above, he would call onIdentify complete, and he could pass in those exact values that are scoped above, and they would still be correctly passed down into the completion function.
That's right, and in addition to that, we generally try to wrap all of our callback functions and event handlers in either closures or lang.hitch blocks so that we can avoid kind of the total scope of the function from jumping around from object to object. Does that help? Okay, any other questions?
I'm kind of curious about in-depth testing asynchronous functions. And I wonder if you consider that to be an anti-pattern, if that suggests that you don't have your code structured or you should be using a fake or something like that.
Yeah, I mean, that's kind of the whole, so the question was, when you end up having to test asynchronous function blocks, is that something that should be avoided? How do we get around that, or how do we test that? And that's one of the main things that we break up our code like we do to avoid that, right? So we don't want to test necessarily that, that the promise resolved. We don't that gets sloppy, it gets hard to write tests, and when tests are hard to write, they just don't get written. So what we'll do is we'll separate again that function that's handling the return of that promise, and we'll write a test on that function. The fact that the promise exists is enough to me to know that it'll probably get resolved.
So it sounds like that if you find yourself needing to do an asynchronous test, that probably suggests you need to.
Yeah, you want to take a step back, look at how you're handling things, make sure your callbacks stepped out into another function, your error handling stepped out into another function, and you might just want to look at how that promise is created and where it's created. Sure thing. Any other questions? All right, thanks everybody. We'll be up here for a little while.